Today we are going to discuss topics related to failure analysis and non-destructive testing. I am Dr. M.Armstrong, Assistant Professor, Department of Mechanical Engineering, Pearson College of Engineering and Technology, Zurich. So before going to the session, we will have some a small quote. If you can't fly, then run. If you can't run, then walk. If you can't walk, then crawl. But whatever you do, you have to keep moving. So it's a word, it's quote said by Martin Luther King. What we want to understand from this quote is, as a student, we are having more drawbacks as well as discouragements, demotivations. In many ways, we can't able to go further. Whatever the things we are going to try, it will become some because of some schedules or because of some other works. We are having our demotivation from our friends or family or by neighborhood. So it will make us to not to move from whatever the goal we want to achieve. So as we want to overcome that, as well as we want to move over that by whatever the time being we can able to make. That the quote which is very very sensational. It is saying like, if you can't fly, you then run. If you can't run, then walk. If you can't walk, then crawl. So if you can't walk also, we can able to crawl by step. We can move smoothly and we can be able to achieve our target. So be happy in your mind that we want to work hard, as well as no demotivations or no discouragements. Move further and achieve your goals. That is the thing I want to say from start before starting our session. So next we'll move on to the next. That is, we'll focus on first of all we'll do what is non-destructive testing, because I'm going to cover like the basic concepts in non-destructive testing, as well as we are going to see the types of non-destructive testings. In that in this session we are going to focus on two things, that is two important testings, and in upcoming sessions we will go further by checking other learning other types too. So okay, let's move on to the class. So what is non-destructive testing? So non-destructive testing, from the word itself we can easily understand, it's a testing we are going to do without any or causing any damage to the material. Whatever the testing we are going to do, like mainly these testings are used to evaluate the quality, the integrity and safety of material components or welds without causing any damage. That is a very important thing you want to have in your mind, because mostly we are having destructive or mechanical testings, but these, by overcoming those testings and as a updation or upgradation, we are having a non-destructive testing which we can able to do without any disruption or without any causing any damage to the material. We can able to test those materials. For example, if you say some defects like cracks or some pores while manufacturing or while casting, some pores may be present. So those may cause the material failure in due time. So what we want to do is, we want to, after completing those manufacturing, or you can able to say weldings application I'm saying, we can able to go through that whether that material is having any cracks or pores while doing some such a manufacturing process. So these testings are very much helpful without causing any damage, without making that material to get damaged, and we can able to test it. So these testings are becoming nowadays very popular among all industries. So we'll see one by one. By defining that, we can able to easily understand. So it's an inspection or testing. It's one of the technique which is used to evaluate the quality, integrity and safety of material components or welds without causing any damage. So this is the thing we want to do without have as a definition for non-destructive testing. So what are the applications we are having? Where we apply? That is the second question we want to have. We have defined it, but we want to know where this non-test testings are applying. So first of all, we want to see the mechanical engineering department. Most of the, like you say, many departments in mechanical, we are having manufacturing departments, quality related departments, building sections, automotive sections. So many sections we are having. In all engineering, mechanical engineering aspects, we can do this because all industries are mainly working under the manufactured components. So wherever the manufacturing components, with the help of the basics involved in mechanical are being there, so those components can be tested with the help of NDT. Welding and fabrication, especially in welding and fabrication, we will always we will go for doing NDT because the weld, how the weld is forming, any damages or without our visual inspection, while going visual inspection also maybe some thing may be miss. So during that time also we can do this NDT by seeing what are the main defects or pores or any cracks which are present in the or any inclusions, either any foreign particles are present in the weld while doing, as well as after completion of the weld, because which will helpful for the material to extend the material life. Okay. The next, power plants, pressure vessels, aerospace, automotive manufacturing, oil and gas, and many applications we could do this. So mainly, as I told, we are going to focus on the types. So what are the types you are going to see is, first one is visual inspection. This is one of the simplest and most economical inspection in NDT, which will inspect with the help of our own eye or some tools like magnifiers, mirrors or boroscopes. So we'll see all these types in detail in upcoming slides, but just I'm saying what are the types. It's present in a brief manner. So first we can see the visual inspections. From the word itself, we can easily understand that visual inspection deals with our own eye by checking the cracks and pores and how much the extension it is happened. Okay, and next one, ultrasonic testing. So ultrasonic testing, here also we can see easily with the help of we can understand very easily by checking the title, even like ultrasonic testing. Ultrasonic nothing but it's a sound wave with the help of some frequency, with a high frequency of about 1 to 10 megahertz. It's not here by our ears, because we can able to hear only 20 hertz to 20,000 kilohertz, not the megahertz. Only hertz, kilohertz we can able to as a human ear can bear, but it is higher than that. Am I right? It is going beyond like megahertz, so 10 above megahertz. So these ultrasonic testings, ultrasonic waves, you can able to see some animals also using these ultrasonic waves for doing their day-to-day life. Example, we can say the bat. Bat is transmitting the high frequency ultrasonic waves to detect traps, or their prey can be detected with the help of the ultrasonic wave which is passing in from its body. As well as you can see the other animals, we can say like dolphins. Dolphins also emitting ultrasonic waves similar to bats to catch their prey, as well as because dolphins underwater. So it's transmitting ultrasonic waves to check whatever the hurdles or anything which is while moving, while traveling, and to find prey also it is using its ultrasonic waves. So similar to that, we are having bat like dolphin. We are having cats and dogs, which is also having megahertz of you can detect up to 60,000 megahertz, kilohertz. So 60,000 hertz up to, am I wrong? I don't know exactly, but approximately it is 60,000 hertz, which can able, the cat and dogs also can able to check the silent. We can't able to hear that communication between the two dogs or two cats, but they can able to do that with the help of the ultrasonic by silent waves they are sending. So these are why I'm saying why this much importance means, because we have as a human, we as engineers, we have used that ultrasonic to find these defects by passing by passing ultrasonic waves in the metal surfaces or the surfaces we are going to detect the entity, detect the failure or cracks. So which can able to easily the ultrasonic waves passing can be easily detected with the help of the digital display, where we can able to see the peaks, how much the crack or how much uh, the the failure which was occurred because of some machining process. These can be easily verified with the help of ultrasonic testing, which is most popular among many industries, especially in oil and gas, in pipeline industries. This ultrasonic testing they are using in very frequent comparatively to visual inspection. They will use visual inspection, but they'll go for ultrasonic testing too, because it's also in a easily portable and easily the reduction can be done. So these testings also we will do importantly in pipelines and oil and gas industries. So next testing we can see the radiographic testing. So similar to ultrasonic waves we are using, we also have the X-rays or gamma rays. There we can able to use these rays to find the internal structure damage, or you say with the help of digital detectors, or we can able to generate the films to find how much you can see here. We can able to see the digital display, and we can able to see the weld component, how much the weld was finally done, or any cracks or pores are present with the help of the X-ray films, as we are using in medical field, like ultrasonic also we are using in scanning, and radiography we are using for X-rays for finding the bone damages in our body. Similar to that, if you take the example of our bone body, that is the body we are detecting any damages in our bones like cracks or something. Similar to that, here also the X-rays are used to find any cracks or any internal damages which are present in the materials, okay, especially in components which are which we don't want to make any damage to this material. That is a very fine very advantageous thing we are having in NDT. We don't want to damage the component, but we can able to detect the defects, which is very easily with the help of these instruments. So as I mentioned, we use X-rays and gamma rays to find porosity, slack waste, like waste inclusions, like some you say some foreign particles are present while welding, any other particles are present in the welding process. What will happen? It leads to corrosion. So it's a very difficult for us to maintain the life of the particular material. So we need to go for such reductions to remove those and to increase the life of the component. So next type we can see that we can able to see these dye penetrant testing, or we can say liquid penetrant testing. Okay, the other name for dye penetrant testing. So these penetrant testings also we can able to do similar to the other techniques. So here we are applying some dyes or as a liquid penetrant, like the spray you can see here. This is a welded part, and we are applying the spray, and we are seeing with the help of visible our naked eye, we are seeing any pores or any cracks or just present, any defects are present in this particular welding welded component. So we will see this dye penetrant testing as well as visual inspection testings in detail in the next slides, but try to understand we are having different types of ultrasonic testing which can be able to use for different purposes. If you are going for in-depth measurement, like the cracks or pores which are not able to seen in the surface, we can use this ultrasonic testing and radiographic testing. If the pores or cracks we can able to visibly see in over the surface, we can go for visual inspection, or we can use this dye penetrant testing. So according to the usage or applications, we can use either of the testings for getting a proper accurate answers measurements. Okay, So magnetic particle testing is the next testing we are going to see. This is simply we can able to, with the help of word, as I mentioned earlier, the help of the word itself we can understand what is this testing is. Magnetic particle testing. So with the help of the magnet as well as the magnetic flux and magnetic particles, we can detect the cracks or the defects in the material. So here we will use this method, the magnetic particle testing can be done only in the ferromagnetic materials, not in all the components we can able to use it, since the magnetic flux or magnetic field is playing a major part. So this magnetic particle testing can be done this is one of the disadvantages I say, like we can able to use only in the ferromagnetic materials. So it supplies a magnetic force or the magnetic flux over it, and due to some leakage, magnetic flux leakage, the particles which we are applying over it, the magnetic particles or ferromagnetic materials like small particles will apply over it. So those will accumulate in a particular position where the crack or a defect was formed. From that we can able to easily understand that this crack is there, or it may be measured near or the nearby surfaces also, like either it can able to occur in the surface or a nearby surface. So internally also if it occurs, we can able to detect the defect with the help of magnetic particle testing. So we want to have magnets and magnetic particles. Sometimes we will use fluorescent particles also for getting much visibility with the help of UV lights, and we can able to visualize the cracks or pores very in a exactly accurate way. So for that we will use fluorescent particles also instead of replacing magnetic particles. So these are some of the types of say the NDT. So here you can able to see the example, like it's a huge pipe. There we are detecting with the help of ultrasonic testing. They are using a probe to send the ultrasonic waves into the pipelines or metal component. Here you can understand the display is showing every movement of the peaks, how it's any cracks are present. If the crack is present, the peak will be very high, or the peak distance will be very high. With the help of that, we can understand some crack or some defects are present in the component. So some of the testing we have discussed. As a summary, I can say we have seen visible testing, ultrasonic testing, radiographic testing, magnetic particle testing, and dye-penetrant testing. So I'll move on to next slide. So we'll see now what is the difference between mechanical testing and mechanical testing and non-destructive testing, or either name we can give, like mechanical testing can be called as destructive testing too. What are the differences? We can see one by one. One is first part is non-destructive testings are testings which inspects the material or the welding component without causing any damage. But destructive testing is a testing where the materials are damaged and we can detect any defect in that particular why it was occurred, the failure was occurred. That can be done with the help of destructing the material, damaging the material. That is the main drawback in this particular destructive testing compared to the NDT. What are the methods? We have seen different methods or the types involved in NDT: ultrasonic testing, dye-penetrant testing, magnetic particle, and some other testings. So here you can see the methods involved in destructive testing. Actually, we study all these things in strength of materials, especially bend test, tensile, impact, everything. So here you can see the material which is applying, the force which is applied over it, or the load which is applied over it, to check the material properties, whether the material can hold this much amount of load or which can't able to hold, because different materials hold different loads. With the help of that, we can able to use it in different applications. For strong materials can be used in high load application places, and the low materials can be low strength materials can be used in for different purposes. So lightweight materials, tensile materials, crack brittleness, and so many testings can be done in mechanical testing. But all those testings are done by damaging the particular material. Okay, that is the difference between NDT and the mechanical testing. So effect of material, no damage to the component can be used again, but here you can say the material is damaged and destroyed during the testing. We can't able to use it again. So we want to see whether the testing we want to use either mechanical or NDT based on the material's importance. So application, we can say in-service inspection, while going for inspection, and so safety and reliability, early defect reductions. So material qualification, research and development, they will use the mechanical testing. So both testings are very needed, and we can't say the mechanical testings are major or not involved or should not involve, because mechanical testings plays a major role in finding the material properties compared to NDT. While applying the load and while breaking the system, we can able to see the fatigue nature of the how much fatigue or how much the load which can able to withstand in by a particular material. So the balance in using the NDT as well as the destructive testing we want to have, where we want to use the GT and where we want to use NDT, that we want to decide and we want to go for it. Okay. So balance in NDT is needed, safe and quick, but DT will give accurate, detailed measurements for the quality. Okay. So we move on to, I hope you have understood the mechanical and NDT techniques, the difference we have seen here. So some of the some videos I have downloaded from YouTube for understanding in a better way. So we'll see that one by one. This is nothing but one of the testing they are doing, the ultrasonic testing. Here you can see the pipeline. You can see the huge size of the pipes which is underground, and they are digging and they are measuring how much the weld quality they have done earlier with the help of the ultrasonic testing. So these type of testing we can't able to do in mechanical testing, because we can't able to break the system and check the measurements for understanding the failure. So these type of testings are very much needed while going for applying in the real-time applications. So henceforth, these testings plays a major role in high factor in oil and gas industries and pipeline industries for using this type of NDT techniques. So next testing, we can see the LPT, nothing but a liquid penetrant testing or dye penetrant testing. Here you can see they have welded the component, and after joining the component, they are just testing whether the component were placed very properly or any damage or present. So here you can see that the dye is applied over it, and they are verifying with our visually they are verifying any damages or any cracks or pores are present. But because now itself here you can see a pores, so now itself we can able to detect these parts, means the lifetime of the system can be increased. So for that we need this type of studies. This is one of the mechanical testing, the tensile testing. Here two machines are applying load, and it is checking whether the stretching of the material is up to which value they are giving in graphs. So mechanical testing, we are damaging the material, but here we are not damaging, and we are checking the testing the materials. So we will go to the next slide. So what are the objectives of the NDT? So the main objective is to detect the defects. Wherever the defects are present, this NDT can help to detect, and we can able to resolve it with the help of the solutions which can able to apply by getting the values from NDT. So ensure product quality. The quality of the product can be enhanced by using this NDT techniques. and improve reliability of the products. So the reliability of the product, if increased, our manufacturing, the we can able to increase the reliability of the people also, and we can able to sell more amount of products to the many industries. Enhance safety. Those who are working under this particular component, the workers' safety can be able to confirm with the help of the data we are getting from NDT that this is a reliable one as well as a safer one. We can able to apply it. Reduce maintenance cost. So while all these are perfect, all the above are perfect, so we can able to reduce the maintenance cost by checking the defects earlier, because if we are finding the failure in a due time after we are doing some process in the system, what will happen, the total machine will be go for the stop. It will stop, it won't work, right? So the maintenance cost will get increased, and it will totally affect the total cost of the material. So this can be reduced by using NDT, and we can reduce the maintenance cost. Why NDT matters, or why NDT is needed? Prevent catastrophic failures, sudden failures which is occurring, and improve product quality as we have seen earlier, and ensure compliance with standards. Whatever standards we are following to manufacture the particular product can be applied in a same fashion or percent, and the standard can be followed in a better way by checking the material properties, and reduce downtime. So we can able to reduce the downtime of the machine, so that we can able to increase the product manufacturing, and we can increase the product level, and which will lead to the increase in the profit we are able to aim for it. So extend service life. While doing such a NDT measurements earlier, we can able to prevent the failures, so we can able to go for the reliability, as well as we can extend the product life by checking a frequent NDT checks. So these are very important points to know why the NDT matters. We have seen the applications, the similar applications we can see, like aircraft structures, pressure vessels, pipelines, railway components, nuclear reactors. So all these applications we can use the NDT. So advantages and disadvantages. So NDT advantages, like it's a non-destructive, we are not damaging the components, and we are measuring the mainly the defects, and it is cost effective. It's not high cost, but it's costly, but it's not up to the market while checking the testings, while testing the material defects. So it's most cost effective, and because we see visual testings, LPG, some simple testings like these testings are very cost effective compared to UV and radiography, but magnetic particle testings are cost effective testings. We can go for it. Portable equipment available. All equipment what we are using in NDT are easily portable, and there is no need for giving traveling cost for it. We can, as a human, we can easily you can take the equipment easily in our hands, and we can go, and wherever the testing is needed, we can able to done. Any defect reduction. So the defects can be detected earlier without any time delay in this goes for failure. So error detection is possible while applying NDT. It's a real-time inspection. We don't want to remove the parts or remove the component from the system for detecting the defects. We can use it in a real-time inspection while the machine is under working. We can able to stop it, and we can able to measure all the main thing we want to measure it. So the defects are while the machine is working very correctly or not. Like it can also measure the vibrations. It can also measure the temperatures. We are having different very varied components for that, or tools for that to measure. So the vibrations and the temperatures, the sounds, how it's doing, everything can be measured, and from the data we are getting, we can easily find the defect, what is happening, or how the machine is working, and how much time the machine can able to work So all those are next level of failure can occur. Everything can be detected with the help of entity in real time while the machine is working. Okay, on that particular time itself, we can able to see, and we can able to detect very quickly and precisely. So applicable to complex geometries. So complex geometries also we can able to measure any defect present in the particular structures. What are the limitations? Whatever the advantages have in entity, some limitations also there. Like all entity techniques are not used by everyone, so there we need some the practical experience, as well as the learning over how the equipments are working. So a skilled operators are required. That is the main limitations we are having. Everyone can able to use, every workers or every operators who are working the machines can't able to use the entity. Skilled operators are required, and interpretation errors are possible. So while measuring, maybe because of some the uncertainty, there may be some errors may possible. Due to that, the material failure may occur after measuring the entity also. So a proper skilled operator as well as a proper kit what we are using, that decides the limitations and errors. We can able to limit the errors, and we can exactly say and precisely we can able to mark the how the component and how the defects are. So that has to be taken care while going for the entity processing. Next thing is some methods detect only surface defects. So some methods detect only the surface defects. It's like visual testing you take. Visual testing, we can able to see only the surface. We can't able to go beyond the surface. So for example, if you say a pipeline, if we take a pipe, we can able to see the surface of the pipe. We can able to mark where the defect is. But inside the pipe, we can't able to detect with the help of visual testings or liquid penetrant testings. So some testings are having limitations on you can able to detect only the surface, but we can't able to go in depth measurements. But for that we are using some we want to use the ultrasonic testings or radiographic testings to find mainly ultrasonic testings to find the in-depth measurements. In some places we can use magnetic particle testing. The near surface discrepancies can be measured with the help of MPT, that is magnetic particle testings. But mostly visual testings and liquid penetrant testings are not possible to go depth. So some limitations there in some testings. Equipment cost can be high. Like for example, as I mentioned earlier, even though it is a cost reflecting a total system, but equipment cost plays a major role. For example, if you say UV and radiography testing, we need some equipment to be utilized. So those equipments cost are somewhat it is higher comparatively to other visual inspection testings or liquid penetrant testing. But we want to utilize it for the overall reduction in the cost. So it is not a major problem. While it's a one-time purchase and one-time investment, we can go for it. So no problem in investing that. So results may require validation. Validation should be required after confirming the entity data. So already we have seen the classifications like visual testing, liquid penetrant testing, magnetic particle testing, ultrasonic, radiography, and some other testings we're having like eddy current, leak testing, and acoustic emission testings. So these testings can be done under the entity techniques. It's completely based on a defect location, material type, and the inspection requirements. So we will see the visual testings. I have consolidated these slides in a single slide with the help of the AI tool. You can see here and the visual inspection testing. We'll see one by one. We'll go through it. So as I mentioned, visual inspection testing is the simplest and most economical entity method, because we don't want to use any high equipment cost is required. So we can go for visual inspection at first, Anything we can't able to detect it. After that, with the help of visual inspection, we can go further by utilizing some high cost equipment like UV or radiography. So every NDT officers will go for inspecting the component with the help of both visual inspection, as well as they will use UV or some high equipment, high observatory equipment they will use. So visual inspection is the simplest and economical type of NDT method. It detects the surface defects. It can't able to measure in-depth defects, but it can able to detect the surface defects by direct observation with or without aids. So these are the some types of visual inspection. So we are having two types. One is unaided visual inspection, another one is aided visual inspection. So I am going to compare two things with the help of this. So unaided visual inspection is nothing but without any tools. We will use our naked eye to measure or find any defects is present or not. Second thing is aided visual inspection. Here we will use some tools to measure the or to clearly visualize what is there exactly in the particular location for finding the defect. We will use some tools. So those will come under aided visual inspection. Okay, we will see some of the tools. So basic tools in unaided are our naked eye and flashlights, mirror. These are simple tools. So we don't want to use these as complex tools. Simplest tools to measure, because in flashlights we use in dark places. We need these flashlights to measure or to visualize how the defects are. And mirrors are used to find or magnify the defect to see it up. And scalers and rulers to measure, and chalk to mark. So all these are some unaided low tools to measure the help of NDT as a visual inspection types. And second is aided visual inspection. We are having LED torch, headlamps, floodlights, fiber optic lights to exactly locate and to measure the particular defect which is present. Some optical aids like we are having magnifying glasses, hand lens, pocket magnifier in unaided parts. But here you can see the exact aided tools like boroscope. The boroscope, fibroscope, videoscope. So all these are utilizing. However, like how we are utilizing in medical fields is similar to that we are using in NDT also. A similar or body inspection is compared with. We can able to compare the body inspection to that of the material component inspections. So boroscope, you can see we can use this boroscope. We are having a camera, so we can insert this fiber into the pipes, and we can able to see whether any defects are present. Similar to boroscope, fibroscopes or videoscopes also plays the same thing. Measuring gauges, we use vernier caliper to measure how much the defects and the thickness of the gauge. Everything we do with the help of these some tools. So here you can see we can detect with the help of camera, smartphones, and inspection mirrors, measuring tape in aided inspections. So common defects you can see here, the cracks are present. We can easily visualize with the help of our naked eye, and we can say some defects are present. Likewise here we can see corrosion, fittings, small pores or holes in the surface, misalignments and porosity and belt discontinuity. Everything can be done by using visual inspection itself. Defects, and we can able to resolve it after finding how much the defects were found. So these are some of the visual inspection techniques we are having. So these are used in wells, pipelines, special vessels, structures, machinery, aerospace and automotive industries. Simple advantages like it is simple and quick, low cost, no power required, first line of inspection, wide applications we can use it. So these are some of the visual inspection we can able to measure it up with the help of visual inspection in this technique. We can move on to next slide. This is our final slide going to our final topic we are going to discuss here. So liquid penetrant testing. So LPT, as we know, From the word itself, we can understand we are going to penetrate some liquid over the surface and we are going to measure it. As we have seen in the video, you have easily understood we are spraying some liquids over it for finding the defects in that particular system. So I have consolidated into a single slide with the help of the AI tool. You can see here we are going to visualize the liquid penetrant testing, how it's working, its procedure and flow diagrams, everything. We'll see one by one. So here you can see that simple definition for liquid penetrant testing. So it's a non-destructive testing method used to detect surface breaking defects in non-porous materials. So in porous materials, we can't able to use this LPT. So you know what is the difference between porous and non-porous. In porous materials, if you are using LPT, the liquid will flow over the complete surface. So porous materials, it's completely showing some defects are there if you are using LPT as a technique. But in non-porous materials, it's an exact smooth surfaces. The surfaces should be very fine and it should be smooth, so that this LPT will give accurate and precise defect locations. But in porous materials, we can't locate the help of liquid penetrant testing. As we know, the basic principle behind the liquid penetrant testing is a capillary action. So all we know what is capillary action is. We have gone through fluid mechanics. So capillary action is nothing but a spontaneous action or a spontaneous movement of spontaneous flow of liquid in a compact or pipes or surfaces against the gravity. Okay, so that will gives the principle of the liquid penetrant testing. So capillary action plays a major role. The complete spontaneous movement of the liquid in compact liquid pipes or compact places against the gravity. That is very, very important. Okay, penetrant. So the capillary action can be happened in a basic principle. So liquid penetrant drawn on the surface breaking. For example, if you say the surface, so in the surface you can see some defects are present. So while the application of the liquid penetrant, the penetrant will be flowing and it will be, because of the capillary action, wherever the compact location or compact, we say the small gaps are present, it will flow quickly, spontaneously into it, and it will be occupying the space of the defect, the gap which is present, the distance of gaps or the depth of cracks which is present. So from that we can identify how much depth or how much there is this resolvation is needed to bring back the particular surface in a smoother way. So this penetrant liquid applied over the surface and it will pass over the defects very quickly under the capillary action, and we will flow the developer over it. So penetrant is one type of liquid and developer is something like a powder, it in the form of a powder or any solvents or any liquids. It will be flow after penetrant, applied application of penetrant, we will apply the developer. This developer will easily will grab or will attract the penetrant over it, and it will give you exact visibility how far the defects are occurred. So penetrant and developer plays a major role or significant role in liquid penetrant testing. So we'll see that in a procedure as I given the capillary action, how it's working. So capillary action can be occurring either two ways, adhesive and cohesive of the liquid. So we know what is adhesive and what is cohesive is. So cohesive is nothing but the particles, the liquid molecules itself will attract and it will move forward. Adhesive is nothing but the liquid particle plus the solid particle which is present, the nearby particle which is present. So these both will attract and it will make the capillary action. Liquid molecules itself, it is creating capillary action, that we call it as a cohesive. Adhesive means both the surface of the solid surface as well as the liquid surface which is causing the action, which is called as a adhesive. Okay, so these are simple basic principles as we know already. We will form a meniscus, either it is in a concave or convex meniscus it will form, and we are having some calculations and we are having so many equations to solve that. So don't want to go into the depth, but we'll see next. We'll see the types of LPT. We're having some, by the help of penetrant type. We're having two types: one is visible type penetrant, another is inflorescent penetrant. Second thing, by removal method, we want to remove the penetrant and developer. For that, we will use solvent removal method or water washable method or post emulsifier method. So it is based on the materials and the locations we are doing. These types may be varying. Both visible type penetrant and fluorescent penetrants plays a major role in applying the liquid penetrant testing. So what is the procedure we follow is, first we will clean the surface. We'll remove the dirt, oil or paint or rust, whatever the present or other contaminations over the surface. We'll clean the surface first, and then we will apply the penetrant over it. As we mentioned, as we have seen in the previous video, we can see that some penetrant will be applied over it. For example, in the welded applications, they have applied the penetrant over it evenly on the surface by spraying or brushing or dipping in either way. And after, we'll give some time to get the penetrant to apply all over the surface, so that wherever the cracks are are the present, it will go into it and it will apply over it. Okay, so for that we want to give some time to get cure over it. So that time we call it as a dwell time, up to 5 to 30 minutes we will give. And after that, we will remove excess penetrant with the help of some water removal methods like solvent removal or water removal or post emulsifier removals. We will use some removers and remove excess penetrant which is applied over it, so that we can able to see the visibility of the crack very accurately. For that, we want to remove it, and then we will apply the developer over it. So developer will give the surface defects very. It will showcase or visibly can able to visualize very perfectly while applying a developer over the penetrant. So we can use either dry powder or wet developer over it, and it will attract or it will make that penetrant to come forward, and it will can able to visualize very perfectly on the surface of cracks, surface cracks. So next one, inspection. After that, after applying developer, we will go for inspection over the complete surface, whether any defects are present. By through the help of our naked eye, or we will use some UV lights. If you are using fluorescent particles for as a penetrant, these UV lights are very helpful for visualize that in a very fine way. Next one is post cleaning. After completion of the particular liquid penetrant testing, you want to clean the component completely with the help of any solvents, either water or some solvents, to remove the complete penetrant as well as developer. Because if we leave it as such, what will happen is these penetrant and developer will itch the parts or itch the component, and it will create cracks or pores over it. So after completion of the application, the inspection, we want to remove all the developer as well as the penetrant by cleaning the components. So it will reduce the itching or corrosion which is occurring with the particular penetrant or the developer we are using there. So here the defects, some defects is detecting, like cracks. You can see that how clearly it is giving the cracks position and porosity positions, and you can see the seams either in laps or pinholes, or we can able to measure it, and shrinkage cracks. Everything can be detected with the help of LPT. So these are some of the flow diagram I have given. A similar thing we have discussed in the procedure itself. What are the advantages and disadvantages? So the advantages are simple and easy to use. High sensitivity to open surface defects. So surface defects can be measured very in a high sensitive way comparative to visual inspection. So inexpensive and portable. Cost wise is very effective comparative to other entity testings next to visual testing. Applicable to wide range of materials. So all materials can be used only, but you can able to use only the non-porous materials, not the porous materials. That is the only drawback. So here can have limitations. As I mentioned, defect can be able to see only in the surface, not in depth. We can able to measure it. Only surface defects can be measured with the help of LPT. Surface must be smooth and non-porous. Very very important. If it's a porous, we can't able to measure with the help of LPT. Requires thorough cleaning because after completion of our inspection, we want to have a thorough cleaning. As I mentioned earlier, these developers and penetrants may cause the itching process or corrosion can be occur. So the complete cleaning of the thorough cleaning of the system after inspection is needed. Not suitable for rough or porous materials. As I mentioned earlier, porous or rough surfaces can't able to measure with the help of LPT because everything will be seen as some cracks or pores or something. So we want to use it only for non-porous materials. So that's all for our topic today. Thank you for listening to the session. We will, as a summary, I can able to say we have seen a simple definition of how the NPT, what is NPT, what is importance of NPT, and after that we have seen what are the applications we are using in NPTs, what is the difference between NPT and NPT as well as mechanical testings or descriptive testings, and then we have move on to types of NPT. Like we have seen from visual testings, some glance we have seen over the types like visual testings, ultrasonic testings, and we have seen LPG, liquid penetrant testing. Then we have seen that is radiographic testing, magnetic particle testing. Some glance we have seen. After that, we move on to an in-depth analysis on how the visual testing is working as well as LPT is working. I hope you have understood the session about LPTs, like NPTs and its types. In the next class or next session, we will see the other types of testings, how it's working and its procedures. That's all. That's all the class today. Thank you so much. We'll see you in the next class.